Hey students, in this video I'm going to go over how to solve systems using the technology, and by technology is our graphing calculator. Okay, so now that you have experienced what it is to write matrices, now you'll be getting answers on the calculator in matrices format. So this is going to be called a reduced row Euclidean form, so it's abbreviated as RREF. So it's a program that the calculator has, and it will do the work for you, but you just need to interpret the answers along with making sure you type the answers correctly. There are three different ways that you're going to get the answers. There's the diagonal ones across, 1, 1, 1, and that will be whenever you have one solution. And the reason why that's when you have one solution is because this follows the format of x, y, and z and the constant. So when it has 1, 0, 0, that means 1x. So x equals 2. When it has 0, 1, 0, that means there's only one y. So y equals negative 5. And then 0, 0, 1 means 1z. So z equals 3. So these are the equations that result from this format, meaning they're giving you the solution right away. Okay, so the other way that you're going to get answers is by seeing zeros all the way across in the bottom row. So the bottom row gives you those zeros all the way, and it's creating a statement because there's no x, y, or z here. So it's just the statement saying 0 equals 1. And it's a true or false statement, so 0 is not equal to 1. So when that is a false statement, you end up with no solution. The other option is going to have zeros all the way across, but all the way. So that means that you don't have any x, y's, or z's, but it equals 0. So this is a 0 equals 0 statement, and that is true. So it's a true statement, and it's in the bottom row, and that's when you have infinite solutions. So those are the three things that you'll be interpreting whenever you use your calculator to solve for systems. Here are the steps of the calculator. I do have the electronic version of this to show you. So I advise you all to go here to calculate by pressing letter A. Others are used to going to this part of calculator. Both work. So either open a calculator there or go to calculate, as long as you are able to just type the steps. So the first step, according to this, is that you're going to type. Sorry, I'm going to fix this. Okay, there. So you're going to type RREF. You have to type that to open up the program. So you're going to press the letters RREF on the keyboard, open a parentheses right here next to the 0. And when it's inside, the instructions say that make sure the cursor is inside the parentheses, and you're going to click on this button that's next to the number 9. So we're looking at this little button right here next to number 9. You're gonna have to move around until you highlight this matrix right here. Whenever you get it, it'll allow you to set up the matrix. So you're gonna click on it, and you're gonna choose 3 rows and 4 columns. So you can type your whole 3x3 system. So I know that some of you are not tech savvy, but just play with it until you make sure that you get that 3 on the top and then 4 for the number of columns. So once you have that, you press OK. And then this is the setup where you're going to type your matrices that you have for the system that you're trying to solve. So it doesn't emphasize here, but I'm going to add the make sure that your matrices are following that format of having the x, y, and z on the left side of the equal sign, and then the constant on the right side. So if your system is not following that, you need to first rewrite it, and then you type it in the calculator, and it'll be able to give you the answer. So here are 3 problems that I'm going to go over in the video. So first, I just want to make sure we verify that they're following the format of x, y, z equals a number. So this top row has the x, y, and z equals a number. Second row, x, y, z equals a number. And third row, x, y, z equals a number. So this one's all ready to be written as an augmented matrix. Let's quickly write that down. We have a 2, a 1, -1, and a 5, 3, -2, a 1, and a 16, and a 4, and a 3, and a -5, and a 3. So that's the first thing you want to do. Verify that it's following this format of x, y, z equals a number. After that, you write the matrix. And now that you have the matrix, you're able to type it in. So right here in your calculator, once again, just to clarify the steps, you are going to type RREF using the keypad down here, parentheses, leave the cursor in there, press the button next to 9, press this one that looks like a matrix of 3 by 3, and then here you adjust that you actually want a 3 by 4, 3 rows, 4 columns. And then now you type the matrix that you have created right here. So we're going to type numbers 2, 1, -1, 5, 3, -2, 1, 16, and 4, 3, -5, and 3. After you type all the numbers carefully, you press enter, and the answer comes out. So you just have to interpret what that answer means. So right here, I'm going to write down the answer that you have here. So 1 diagonally, 1, 1, 1, 0, 0, 0, 0, 4, -1, 2. So on your notes, you should have written the answer that you get in the calculator. And then again, you verify that you have the ones diagonally. And if you do, that is your solution already written. 1x, 1y, 1z. So the solution here is 4, -1, and 2. Okay? So next we practice it again, verifying that it follows the format of x, y, z. So x, y, z equals a number. The top one checks. It's ready to be converted. X, y is not here, but it is on this side of the equal sign, so we need to move it over. We're going to move that -3y to the other side. So the way you move it, once again, is by adding the opposite. So plus 3y plus 3y cancels. And then now you have only a number on the right side. The last equation has the z on the right side and a -1 by itself on the left side. Both of them need to switch. This one goes that way and this one goes this way. So z needs to be subtracted, minus z, and then the 1 needs to be added, add 1, add 1. So that cancels that 1 and that cancels that z. So now our new equation here is -x minus z equals 1. So on the top, remember we moved the 3y to the other side and it became positive 3y. All right, so the first row is xyz equals 5, so 1, 1, 1, 5. The second one is xyz, so 2, 3, 2, and then -3. And then the last one, we rearranged it and it looks like -x, z equals 1. So -1, 0 for the y, -1 for the z, +1 for the constant. So now that we have written the matrix, once again, we go to our calculator and you could just type again RREF, open parentheses, press the matrix, and it's 3 by 4. And then you type the numbers that you have on your paper. So we're going to have 1, 1, 1, 5, 2, 3, 2, -3, and -1, 0, -1, 1. And the answer on this one, we're going to annotate it here. So 1, 1, 3 zeros on the bottom. I know we all copied it different order, but overall, this is what I end up with. And then this is the one you realize that 1, 1, 1 is not going down diagonally. You actually have the 3 zeros in the bottom row, and that leads to no x's, no y's, no z's. So it leaves you with the statement of 0 equals 1, which is a false statement, which means the answer is no solution. Okay? All right, last problem together. We have x, y, z on the left side of the equal sign. However, they're out of order, so I'm just going to rewrite them in the right order. 6x plus 4y minus z equals 0. So now they're rearranged in order on the left side of the equal sign. The second equation has the y on the right side, should be on the left side, so minus 8y on both sides cancels, and you're left with negative 8y plus z equals 16. And then the last equation is fine the way it is, so I'm just going to copy it down. So now let's turn that into a matrix. We have 6, 4, negative 1, 0. There's no x, so 0, negative 8, 1, 16. There's no x, so 0. There's a y, 6. There's no z, 0. And the number is 3. So now we're going to write that matrix in our calculator. And once again, it's RREF to open up the program, open the parentheses, leave the cursor inside the parentheses, click on the matrix, it should be 3 by 4. Type the numbers that you have here inside your matrix. So 6, 4, negative 1, 0, 0, negative 8, 1, 16, 0, 6, 0, 3. And the answer we get is this one. So I'm going to copy that down on the space here provided. So 1, 1, 1, 0, 0, 0, 3, 1 half, and 20. Okay, so I know we don't really like working with fractions, but this one does have the 1, 1, 1 diagonally, which means that this is an x, a y, and a z. So 3, 1 half, and 20 are the values for the solution. Okay, so you're going to go ahead and practice on the bottom 3 examples, and I hope this video helps you.